Hi everyone, and you are welcome to Dependency Inversion Principle lecture. In this lecture, I'm going to discuss with you the last principle in solid design principles. And as usual, let me start by a quick question. Assume that you have a method which updates an instance attribute of an object from another class. Should this method directly update the instance attribute using dot operator, or update the instance attribute value via a method provided by the second class? If you are not sure about the answer, join me in this lecture. In this lecture, you will understand what DIB is, then we will discuss this concept by a practical use case, and finally, I'll end up this lecture by a quick summary. So let's get started. So what's DIB? This principle is very simple actually. It just states that classes must depend on abstraction, not on implementation. So what I mean by this? I mean by this that high-level classes must not depend on the low-level classes implementation, but they should depend on abstractions. To understand these theoretical words, join me right now in Jupyter Notebook to show you a complete example about what I am explaining here. Okay, let's understand this principle by a real use case. Assume that we want to implement an application for online store. And we know that the online store requires the availability of a database. So let's say that I want to define a class for this online store, and this class accepts an object from the database that we want to use. So now, if I assume simply that the database is just an object from the available and predefined class list in Python, after this assumption, I can define the four main queries that usually I am doing on a database on the following way. I can say that if I want to add a product, all what I have to do is using the function like append. And if I want to get product, all what I have to do is using the index, because it's a list. Don't forget that. This is an assumption. And if I want to delete, all what I have to do is using delete function. And if I want to print, all what I have to do is looping over this list item. And in this case, my online store with a database will work without any problem. But don't forget that the assumption is that this database is a Python list. Now, what's the problem with this implementation? Let's say in the future, you find that this list database, it's quite limited, and you want to update or upgrade this database to something which is more advanced, like for example, SQL database or MongoDB. What to do in this case? If you decide to do that, you will find yourself that you have to update all these methods. Why? Because these methods assume that we are dealing with a list. So if I want to upgrade my project, I have to update the actual classes that I have. And this is a big problem as we have seen before. We don't have to update the code that's in a production environment. If we want to upgrade, we have to do that by, let's say, inheritance, by adding new classes, not by updating the actual classes. So the question now is how to make my code upgradable, which means in the future I can change to any database without changing the code of my online store. This is a question. Let's see how we can do that. Okay, the first thing that I will do is I will define an interface to represent the database. How I will do that? We know that if I want to define an interface, I'll define a class. I will define meta class to be ABC meta, and I will make all the methods that communicate with my database, like add product, get product, delete product, or show all products. All of them are abstract method, and I have to redefine all of these methods for any new database that I want to use. So for example, if I want to support list database, what I have to do, I have to inherit this database interface number one, and then I have to redefine all of these abstract methods like add product, get product, delete product, and show all product in the context of list database. So this is what you have to do for list database. Now, the second change that you have to do is now updating the online store class in order to work with the interface, not with an actual implementation. It's quite simple. You will see here that the online store class, it takes in the constructor a database object like before. But look now, when I want to add product or get or delete or show product of this online store, I'm not using any code which is related specifically to any data type, like for example, indexing or using delete or whatever. What I'm doing here is calling the function like add, get, or delete, or show all products that have been defined previously in the interface. So in this way, in the future, if I decided to change my list database into another database, all what I have to do is just define a new class for this database, like for example, MongoDB database, define how I can connect to this database in order to add, get, delete, show all products, and then just pass an object from this database to the online store. In this way, you will see that your online store class will work directly without any problem, without any change, because this class has been implemented assuming that we have an abstract interface, which is database, not an actual implementation of any specific type of database. And by doing that, you are respecting the principle of DIP. That's all, and thank you very much. Now we reached to the end of this lecture, so let's recap what we have learned about DIP. Simply, this principle states that high-level classes must not depend on the low-level classes implementation, but they should depend only on abstractions. Now please, I need you to refer to the challenges available in the lecture resources in order to practice what you have learned. Many thanks for your time watching this lecture, and if you are available, join me in the next lecture.